Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting question from entrance examination. We know that xy equal to 10, yz equal to 20, and x times z equal to 30. And we need to find the sum x plus y plus z. So if you have your answer, your assumption, you can also write your solution in the comments below, and then we will check our answer. So it will be really interesting. So first of all, I want to underline our equation. So xy times xy equal to 10. This is our first equation. Yeah, y times z equal to 20, this is our second equation, and x times z equal to 30, this is our third equation. So as a first step right here, I just want to multiply first equation. Yeah, I just want to write it in this circle. So first equation, I just want to multiply it by the second equation, and I just want to divide it by the third equation. So I really hope you understand it. This is our first step. So first equation, xy, we're going to multiply by the second equation by yz, and we're going to divide it by third equation times by x times z equal to, of course, in terms of like values, we have xy equal to 10, so we have 10 times yz times 20 and divided by xz by 30. Right now on the left side, one really important moment, because we can easily cancel our x right here, we can easily cancel our z right here, so we have only y times y. So on the left side we can only have y square. What we have on the right side, 10 times 20 divided by 30, we can easily cancel, for example, 1 0 right here, 1 0, so we have only 20 over 3. So y square equal to 20 over 3. This is the first equation that first expression that we really need. What we're going to do as a second step, let's do it. So in the second step, let's multiply first equation times the third equation, and let's divide it by the second one. So we have first equation, we're going to multiply by the third one, and we're going to divide it by the second equation. Okay, right now let's see what will happen. First equation, xy, times third equation, xz, and we're going to divide it by the second one, by yz. In terms of coefficient, in terms of our values, xy equal to 10, xz equal to 30, and we're going to divide it by yz equal to 20. Right now let's see what we have on the left side. On the left side we can easily cancel our y right here, z right here, z right here, and as a result we have only x times x, so only x squared on the left side. Only x squared on the left side. On the right side, 10 times 30 divided by 20. We can easily cancel our 10 with this 20. As a result, we have 2 in our denominator. And we can easily cancel this 30 divided by 2. As a result, we have 1 and only 15 in our numerator. So x squared equal to 15. Really great. And we really need one more combination. Let's try to find out how can we find the last combination. So in the last combination, let's multiply the second equation by the third one, and we're going to divide it by the first one. Okay, by the first one. Let's see what we're going to have in this case. Second equation, yz, times the third equation, xz, and we're going to divide it by first one equal to xy. Right now, in terms of our values, yz equal to 20 times xz equal to 30, and we're going to divide it by 10, xy equal to. Right now, on the left side, what are we going to have? We're going to cancel x and x, we're going to cancel y, and we have only z squared. So z squared equal to, right here, we can easily cancel our 10 and 20. As a result, we have only our 2 in our numerator, so 2 times 30 equal to 60. So z squared equal to 60. And right now, just keep in mind that we need to find our x plus y plus z. So in terms of algebra, there's like a really great identity. This is a very helpful identity for us. This identity looks like that. When you have x plus y plus z, when you have this to the second power, this is equal to x squared plus y squared plus z squared and plus 2 times xy plus yz and plus x x times z. This is a correct algebra identity. I don't want to prove it. This is a correct identity because we have a correct expression on the left, on the right side. So this is, I just want to leave this identity like that. This is extremely important. Maybe not a popular identity, but extremely helpful in our case. Right now, let's try to look closely what do we know from here, because we have x squared plus y squared plus z squared. Now let's try to find out where do we have it. So of course we have x squared, we have y squared, we have z squared. So we know everything about this part. We know everything. What about this one? xy, yz, xz. We know everything about it from the beginning. xy, yz, xz. So right now let's try to plug in everything that we know. Okay, so we have x plus y plus z to the second power equal to x squared equal to 15. Yeah, 15 plus y squared equal to 20 over 3. Yeah, 20 over 3 plus z squared equal to 60. Yeah, z squared equal to 60, and plus 2 times xy plus yz plus xz. So we have xy 10 plus 20 plus 30 from the beginning. Yeah, so we have 10 plus 20 and plus 30. Let's simplify it step by step, because right here we're gonna have our final answer, because we need to find x plus y plus z. So let's evaluate, let's simplify our expression on the right side. So we have x plus y plus z to the second power equal to, let's add this 15 plus 60 first of all. So we have 75. Let's leave it like that, 20 over 3. And right here what do we have? 2 times this expression, 10 plus 20, 30, 30 plus 30, 60, 60 times 2, we have 100 and 120, so plus 120. Okay, let's simplify this. We have our denominator 3, we can easily add it. So we have, as a result, right here I just want to write it with the equal sign, because we have 120 plus 75, we have 195, plus we have 20 over 3, plus 20 over 3. Okay, right now let's find our common denominator. So we have x plus y plus z to the second power equal to, we have a common denominator, we have 3. Right here we have 195 times 3, so 195 times 3, and plus 20 times 1. From here what do we have? 195 times 3 equal to 585, and plus 20. And all over we can divide all of this by 3. We can easily add our numerator, so we have 605 divided by 3. So 605 divided by 3. But this is our expression to the second power. So this is our x plus y plus z to the second power. Yeah, we have right here we have this expression, x plus y plus z to the second power equal to 605 over 3. Yeah, but when we apply square root on both sides, we can easily cancel our expression, our second power on the left side. So we're gonna have only x plus y plus z equal to square root of this expression, 605 over 3. But let's try to simplify this expression on the right side. Of course, this is our answer, but we can easily simplify this. Let's try to simplify it. First of all, let's rewrite it. So square root of 605 over 3. Okay, in terms of basic algebra property, whenever you have expression like square root of a over b, we can easily split this square root like square root of a over square root of b. We can easily write it like that. Okay, so we can consider it as square root of 605 over square root of 3. But what about this 605? Let's try to express in another way. So 605, we can easily divide it by 5. Let's see what will happen. We can easily divide it by 5. So as a result, we have 121. This 121, this is our table case. This is our 11 squares. So we can easily divide by 11. Right here we have 11, 11 right here, 1 and 1. So this 605, we can easily write as 5 times 11 square. Okay, equal to square root of 5 times 11 square over square root of 3. Okay, right now we can easily split this 5 times 11 square. In terms of basic school property, we can write it as square root of 5 times square root of 11 square over square root of 3. Right now, this square root of 11 square, we can easily cancel these 2 and this square root. So we have 11 square root of 5 over square root of 3. Over square root of 3. And for better value, for better answer, we can multiply both sides by square root of 3. So times square root of 3 on our numerator and times square root of 3 in our denominator. Okay, we're gonna multiply both sides. As a result, we have 11 square root of 5 times square root of 3, and right here we have square root of 3 times square root of 3. This denominator equal to 3, and right here we can consider it as square root of 5 times 3, so square root of 15. So we have our answer 11 square root of 15 over 3. This is our answer. This is our answer to this question. Yeah, and we're gonna write our final answer. So our answer to this question. So x plus y and plus z equal to 11 square root of 15 over 3. This is our final answer to this question. So I really hope you understand it. I really hope you learned something new. Also write your thoughts, write your approach. What do you think about this question? Maybe you have a faster method. How can we find the sum x plus y plus z? It's really interesting to exchange information, to see how do you solve this question from different perspective. It's also really great to see from your angle. Yeah, this is a really important moment. So thank you for your time. Take care of yourself. Have a great day. Don't forget to write your notes, write your response in the comments below. What do you think about this question? It's really great to exchange information, to see this, to see your approach, because there are a lot of ways how can you solve this question. Maybe you have a different one, because this is like a method of combinations. Yeah, we have a lot of combinations right here, 3 combinations, and as a result we have 3 squares, and then you need to find out how can we use these expressions. And I just use this in this formula. Yeah, basic school formula. Of course, this formula works with a lot of these constant, with a lot of these variables like x, y, z, maybe d, a, b. Of course, you're gonna have a lot of combinations, and of course, this formula works perfectly without z. We're gonna have a basic x plus y to the second power. So I really hope you understand where this formula comes from. Okay. And of course our solution, basic algebraic manipulation. So thank you for your time, take care of yourself, have a great day, see you in the next videos.